Okay, ladies and gentlemen, we are looking at how surface area affects the rate of reaction, right? So if we refer back to our doodle notes here, we can see that this all ties off of the collision theory, right? There has to be enough energy and the right orientation for our collision to turn into a reaction. And so how we have things concentrated, the pressure, the temperature, catalysts, and surface area all impact our rate of reaction. So we are going to be doing a lab here that looks at surface area impacting it. Okay, so do you remember a while ago when we were looking at acids and bases, I showed you that kind of disgusting video about the hydrochloric acid, like the acid in our stomachs, right? And like what would happen if you like dove into a swimming pool of stomach acid? It was kind of gross, but it was all about how we've got this acid inside of us, yet we exist and we don't feel it, except sometimes we do. Sometimes we get those stomach aches, sometimes we get like indigestion or heartburn, and maybe your mom, your aunt, your someone has given you a Tums, right? You've got an upset stomach and they say, here, have a Tums. And if there's one thing that I hear all the time when I take a Tums or I give someone Tums, and it's like, oh, but I don't like them because they're so chalky, right? If you were to describe a Tums, we're going to say they're kind of chalky. So Tums are actually, they're made with calcium carbonate. Calcium carbonate. And so we're going to look at how does a Tums actually help when I've got an upset stomach, when I've got too much stomach acid that's just causing a lot of unpleasantness. Okay, so what I've got here is I have hydrochloric acid, which is why I've got my gloves and my glasses on. So I'm going to just give myself 2 beakers here with some hydrochloric acid in it. And we're looking, remember, at surface area and how that impacts our rate of reaction. So what I have done is I have a pink Tums that is going to stay solid, right? Like what would happen? What would our rate of reaction be if for some reason I hated the chalky texture so much that I was like, I'll just swallow the Tums whole, right? So how long would it take the Tums to work if I just swallowed it whole versus I've got a blue Tums here that I ground all up, right? Like our teeth, right? So we powder up our Tums, and how does that then help the Tums work faster? So I'm going to be having my stopwatch here. Let me tilt my camera down. And we're going to time how long it takes for our reaction to take place. So to start with, I'm going to take my whole Tums, and I learned my lesson with our other lab. With acid, I'm not coming anywhere close to my computer to show you because I don't want to spill it on my computer, okay? So, let me show you here. In it goes. Start my timer. And you can see we've got a lot of fizzing and bubbling. As this calcium carbonate, what's happening is it's reacting with the hydrochloric acid and the calcium carbonate is being broken up. Okay, so that's our reaction that's taking place. The carbon, it goes to work neutralizing the acid, okay? So it's calming down all the acid that's going on here, our carbonate atoms. The calcium then, it goes to work in your stomach, just giving you that extra vitamin to just kind of help your whole system balance out. Now, if you look here, I've still got this glob, right? Still got this glob, so I'm going to try and swirl this around. Still going. Now, most of you guys don't have hydrochloric acid just chilling in your homes. But if you have vinegar and if you have a Tums, you can simulate this a little bit. It's not quite as brilliant of a reaction, but the thing that I want you to try and show you that makes Tums unique here, without spilling all over my computer, is there is a floating film on top of my acid now. It almost looks like oil floating on top of water, but it's like this. It's like this solid film floating on top, and it's kind of showing you what happens in our stomachs is how it kind of creates this barrier when it neutralizes the acids. So it just kind of creates this like band-aid layer so that we're not having such a stomach ache. Okay, so that took us a little over a minute for the whole thing to dissolve, and I've still got some chunks where if I keep swirling and I keep swirling, I could probably get it all to dissolve. But at this point, my hydrochloric acid, it's been balanced out. It's been calmed down by the antacid. That's often how we refer to Tums, as an antacid. Okay, so now here is my powdered one. So I've reset my timer here. We're gonna pour this powdered one in like my teeth. There we go. Our blue doesn't oh, how fascinating. Our blue one is actually kind of pink. An interesting observation in what type of dyes are taking place in our Tums. Okay, so I'm going to swirl this one around. Oh, you can hear it. And we are at the same stage as the other Tums. Okay, so there you can see my floating film. Still got some pieces, but my floating film is there, and that was 29 seconds. Okay, 29 seconds. So you can just see that our surface area, having this more broken up, having more of our Tums exposed, right, spread out versus a chunk, it activated, and our rate of reaction, it was so much faster, right? About 30 seconds faster. It cut the time in half, okay? So how does surface area affect our rate of reaction? All right, so just think about how that all plays into each other as you answer a couple questions on your Google form.